Hello there, and welcome to the Geometer's Compass. This is Jeff coming to you from Dublin in Ireland, and this is
I'm Scott, and on Cortez Island, BC, Canada.
all right. How are you today, Scott?
Doing great. Yeah,
Good, good. Yeah, same here. So, we're going to talk about pie in the sky. Yeah, is that our vibe for today?
yeah.
Okay, so let me frame this for anybody viewing or listening today. Essentially, there's a wonderful pattern that's transmitted by the movement of Mercury in our sky when viewed from the planet Earth. And a lot of these ideas and concepts have come to me from a recent workshop I attended in the UK. Really wonderful place called The Sacred Art of Geometry. And the teacher is a guy called Daniel Doherty, who's absolutely world class. So I couldn't recommend it more highly. I really want to just do a shout out to Daniel. But we spent 3 days essentially drawing the geometry and exploring the patterns of what Mercury actually does, right? And so, Scott, if it was okay, like, I mean, I wanted to sort of share with you what I learned. And
Please. Yes.
basically, there's two ways that Mercury exhibits pi in ways that I think are incredible, okay? And they're pretty simple to understand. So first of all, the core thing to get set before I explain this is that we're viewing the movement of Mercury from planet Earth. Okay, it's called a geocentric perspective. Very often you see the solar system with the sun in the center. Great perspective, the heliocentric perspective, but this is the geocentric perspective.
But
So
you're
what
not
happens is,
you're not saying that the Earth is the center of the universe, but that's just a valid observational frame.
yeah, it's just because it happens to be the rock we're actually standing on.
Right.
So yeah, of course, we're just yeah, obviously, I know we're going around the sun like everything else and blah blah blah. So I'm not making a claim for some wacky offbeat stuff.
Right.
Thank you for the clarification. But basically, like as we stand here on Earth, I mean, Mercury essentially is spinning around the sun just like we are. Mercury spins a lot faster. It only takes 88 days for him to get all the way around the sun. Um, but what happens is we basically when we look at Mercury, essentially, here he is in our view, and then of course he goes around the back of the sun and kind of comes back towards us. Okay. And so because Earth is moving, the amount of time in Earth days it takes Mercury to go from, say, the closest point of approach, right? I think they call that the inferior conjunction. Um, isn't that right? Is it called inferior conjunction?
I don't remember. It could be like perigee or
Oh, sorry, I think
apogee.
it's minor. Sorry, minor conjunction and major conjunction is
Okay.
is one of the. I think there's various ways of explaining it, but anyway, let's just say Mercury at his closest distance to Earth. It takes 116 days exactly before Mercury will return to the closest point again. Okay,
In relation to Earth.
116
Yeah.
days.
Yeah.
Yeah, in relation to Earth, right? So, and then when you divide that time period into the total amount of days in a year, right? You divide 116 into 365, you get 3.14.9 or something. It's not exactly
Oh,
pi, but 3.14 is enough for me to go, oh, cool, that's pi, right?
right.
So I'm not saying it's super, super exact, but I was just kind of like, isn't that kind of random and a cool coincidence and interesting, right?
Yeah.
So that was kind of one finding that we went through and we drew the geometry of the pattern, which I want to show you now. Actually, can I share the picture with you?
Please.
Um, so if we have a look here, this is a sand mandala I've made. Is that coming up in full screen for you?
I see it, but it's kind of filling a small part of my screen, but that just might be me. Don't
Ah,
worry about it.
sugar.
It looks fine.
Okay, so I'm just basically trying to these white tracks are basically the path of Mercury, So these kind of like loops here, these kind of you could say they're like kind of deep red loops, mark Mercury's closest point before he goes all the way back out around the sun. This is the way we see it and comes back in like this. Does
I
that make
see.
sense?
Yeah. So the white is like the path, the relative path of Mercury relative to Earth.
Exactly. And
And we're
Earth is this
seeing,
little dot in the center.
okay. So it
And
makes
if
a
we're looking out,
beautiful flower pattern here. Yeah.
yeah. Yeah, and so Mercury goes every 116 days, it goes ding, closest point, ding, closest point, ding, closest point,
And over a number of years, it takes a number of years before you start to see the whole pattern emerge.
Well, yeah. So for this pattern to be completed, right, it takes exactly 7 years. Okay. And the cool thing is, in that 7 years, the amount of like close approaches that Mercury makes is exactly 22. So here's pi again. You get like 22 close approaches, right? Minor conjunctions, or is sorry, inferior conjunctions. I think they're called inferior, minor, major. Oh, forgive me with the
That's a,
term, but you know Mercury at his closest point. Um, every 7 years, it makes 22 of these close kisses. And then if you divide 22 over 7, that's also an ancient approximation of pi,
amazing. Yeah.
20, 22 divided by 7.
Yeah.
So I was just like, the way sometimes, like Scott, we can get a little bit maybe of pushback. I mean, gentle pushback from our friends saying, "Oh, maybe it's just a coincidence, or maybe we're just reaching at straws. Maybe we're kind of like looking for patterns that we're sort of." But I really don't think that is the case here, because for me, right, the significance of pi as a transcendental number in geometry is so profound, right? The fact that the happen chance arising of the number Mercury just happens to transmit coincides with pi. Even in one expression, like the 116 divided by the full days in a year, isn't it makes it cool enough for me. But the fact then it's a second way where you get this 22 over 7, I'm already convinced that there is something remarkable about pi and Mercury going on,
Yeah, I think
what do you
so.
think? Can you see my vibe for it?
And it kind of reminds me of all of those occasions where there's a very high correlation to something that's maybe in excess of 99%. And that draws my attention, like, oh, there's something interesting about that. But there's always a way out. There's always someone who will say, well, it's not 100%, so that's just a coincidence. And yeah, that's true. But there's certain underlying patterns of the universe that I like to notice. And when something is so like hitting you twice with this information, twice with pi, you start to think, oh, maybe there's a deeper structure there that we don't yet really understand that is resonating with pi. Or maybe there's an intention there, a consciousness that is coordinating that to coincide with pi. And it's never exact. It's sort of, to me, it's like the Fibonacci sequence and its relationship to the golden ratio. So, like, the Fibonacci sequence has integers, you know, whereas the golden ratio is this not never repeating number. And in the real world, you can only have these integers like the number of seeds on a sunflower head. They're going to be discrete units. And so it's never exactly the golden ratio, but it tends towards that limit. And that's the best you can get in the physical universe, is something that points you in that direction. You see?
Isn't it
It,
Plato who says like it's a moving towards the ideal? Everything is an approximation of the perfected form
yeah,
beyond this realm or whatever, something like that.
exactly. And so if you look at the number of seeds on a sunflower head and you count them consistently, they always end up with Fibonacci numbers. And when you divide any two adjacent Fibonacci numbers, you have an approximation of the golden ratio. So there are
Mm.
people who are like, I don't see the golden ratio there. Well, what? Just
Yeah,
look a little harder and
yeah, yeah,
then you'll see
yeah.
it. But there's always that naysayer in the crowd who's like, nope, I need to really have it be literal for me to believe. And then there's the people who are more like able to tolerate ambiguity, able to tolerate multiple interpretations simultaneously. I think that requires greater cognitive flexibility. And I think that's what we both enjoy, is looking at these things and going, oh, that's interesting. It doesn't prove anything, but it sure is interesting that pi seems to be resonating with Mercury. You know, it doesn't prove that it's designed by God necessarily, but you can certainly think that way. It doesn't really prove anything. It's just a suggestive correlation. And I can think of
Mm.
some other ones. It's funny. This morning I watched a YouTube video by this physicist, Sabina. I can't remember her last name, but she's a German physicist who's now a YouTuber. And the video was about interesting mathematical coincidences. And one of them that she brought up was, let me share my screen with you.
Yeah.
It has to do with pi. So this one here is in Chat GPT right now. Let me see if I can make it bigger. And I asked Chat GPT this question: does the mass of the proton compared to the mass of the electron approximately equal 6 times pi to the fifth power? And in fact, it does. And it says it's a rather remarkable numerical coincidence.
Mm.
6 times pi to the fifth power is the ratio of the mass of the proton to the mass of the electron.
Wow.
And she pointed that out, like, is that just a coincidence? Or is there some deeper ordering going on there? And there is
Mm.
no conclusion. It's just like, that's interesting. How is that? Why is that?
Yeah.
And I remember another thing I found when I was analyzing the fine structure constant. This is in my tangents course. And
Mm-hmm.
this article is called Y137. And in this chart, we have different people's approximations of the fine structure constant, which is this really mysterious number in physics, which is very central. And
Actually, Scott, could I ask? I mean, I've done this a million times, but is there any way you could give me a refresher, just like, the short version of what the fine structure constant is?
yeah, here it says the charge of an electron is equal to the square root of the fine structure constant times 4 pi, for example. It's such an elusive thing. It has to do with the atomistic structure of electricity, which is such an essential quality of all atomic sources of electric fields actually occurring in nature. This is what Wolfgang Pauli said about it.
Mm.
Um, Richard Feynman says this great quote. He says, I'll read it to you because it's really a great thing he said.
Yeah, please.
It has been a mystery ever since it was discovered more than 50 years ago, and all good theoretical physicists put this number up on their wall and worry about it. Immediately, you would like to know where this number for a coupling comes from. Is it related to pi, or perhaps to the base of natural logarithms known as e? Nobody knows. It's one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. You might say the hand of God wrote that number, and we don't know how he pushed his pencil. We know what kind of a dance to do experimentally to measure this number very accurately, but we don't know what kind of a dance to do on the computer to make this number come out without putting it in secretly. And so I altered this Rembrandt painting of Belshazzar's feast to
Uh-huh.
show alpha is approximately equal to 1 over 137. That's the fine structure constant, approximately.
Yeah,
And so he's like looking at the hand of God, writing this number down. Um,
I
that's my
dig that.
little pun, I
Scott,
guess.
can I just jump in terms of like, am I right in thinking the fine structure constant is this kind of magic number which is responsible for, allowing atoms hold themselves like just in the right form? Is that what it's
I
linked
think
to?
it's basically allowing chemistry to happen.
Yeah,
It's
yeah,
allowing
yeah.
bonding to happen. There's
Allowing.
another quote in here somewhere that talks about it. There's an interesting thing about coincidence. Um, Wolfgang Pauli was this physicist I quoted earlier, and
Yeah.
he was talking with Carl Jung, and Carl Jung was
Uh-huh.
analyzing his dreams, and they did the book together about it.
Okay.
And then Wolfgang Pauli eventually he got ill and he went to the hospital just before he died, and they put him in room 137, which is the
Oh, wow.
fine structure constant, and um, he knew that was more than a coincidence, you know, because he
Fascinating.
had spent most of his life chasing this number.
Yeah,
Um,
yeah.
yeah,
And
so I mean, you should, if you're interested, if people are interested in this, they should read all the details in this article here in the tangents course.
yeah,
There's
absolutely.
lots of gold in here. But one of the things that's really cool is the fine.
Scott, you might just direct people to that on our website while we're running through it here, just so, just in case somebody's listening to this on audio, perhaps. It's like sacredgeometryacademy.com, basically. I
Yeah,
can do it
that's
for
right.
you.
Um,
Yeah.
and Tangents has all these articles. There's so many in here that I've written in the
Mm.
in the past, and I provided them as articles, also as audiobooks, or video audio tracks you can just listen to, and as well
Hmm.
I read a number of things here that you can watch. It's interesting. I call it a video book, where I'm actually reading it, and you see the video of me reading it, and you also see the text on screen. So
Mm.
it's kind of an
I
interesting
love those, Scott. I really
multimedia
do.
experience. But there's just tons of content in here. Anyway, so
Yeah, I
what I wanted
can't
to
I
point
can't
out,
recommend it more highly. Yeah, check it out on our website, sacredgeometryacademy.com, and you'll find a tangents course there.
yeah, and a
Is there a
subset,
cost for that course, Scott?
is there one?
What is there a cost for it? What's the price of it?
I think it's $33.
Okay, so it's
Um,
it's a and
and
it's
it's
an infinite resource of information. It's so worthwhile.
there's a subset of this that I published as a 700-page book in the past.
Mm,
So it gives you a sense of how much is in here, a lot.
it's
Uh,
amazing, Scott.
but back to
Can
pi,
I invite you
yeah,
invite you back to regular screen? And I wanted to sort
yeah.
of just like ask your, because you've such a kind of a brilliant mind when it comes to pi, and I know that we've spoken about it a lot. But the way you were saying there about how in life, it can be helpful if you can grow comfortable with being okay with things not being complete and not being 100%, and there being something that's kind of elusive and unfinished. Well, isn't pi like one of the great teachers in this regard? And what I'm getting at here is so pi is like 3.14, and then the numbers go forever, right? And allegedly there's no pattern in it, and it never ends. Okay.
And there's no
And
algebraic solution for it. That's what
yeah.
that it makes it a transcendental number. So
Mm,
it's in this very rarefied class in mathematics, along with E, where we really just don't know where it comes from. We know what it is, but we, at the end of the day, it remains a mystery, and we just kind of label it and call it pi.
yeah,
You know,
exactly.
it's not this really wild thing. It's really down to earth, because it's the relationship a circle has with its diameter.
Well, this is what I love, right? Like everywhere we go in our world, right? When we drink out of a cup, when I have a little coaster here, my drums over here, they're all circles. Look around your room, the microphone here is a circle. Like the wheels on our car, the plates we eat our food off, in the most mundane of areas, it's like our entire world is imbued with circles, right? Just look around, they're everywhere. And yet encoded in that very simple, the steering wheel on your car, is this incredible, elusive, transcendental number, right? I'm talking about the relationship. If your diameter of your circle is 1, then the circumference is 3.14 dot 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 forever. And you were sharing with me, Scott, that people have tried to identify or complete pi or resolve pi, and now they're running it on very, very powerful computers. And I heard recently, I think the latest kind of like distance they've gone to is they've run pi to 62.8 trillion digits, right? And I did a fun thing, right? I was like, because I kind of like numbers, I was going, what is like 62.8 trillion, right? And then I turned it into seconds, okay? And I was like, I was playing around with this, and this is kind of cool. Can I share this with you?
Yeah, yeah.
So like some guy on a computer, I should get his name. Maybe we can put it in the notes of this, Scott, but has run pi to 62.8 trillion. And then I said, if I was to convert a million, right, just 1 million into seconds, right, that goes back about 10 and a half days. And then if you go up one order of magnitude to a billion, right, that goes back 30 years, I think. So you go from like 2 weeks to 30 years, just from a million to a billion. Now, if you go to like a trillion, right, you're back in the ice age. Like it's like 30,000 years ago. But if you want to go to 62.8 trillion in seconds, just turn it into seconds, you're going back almost 2 million years BC, right? Like so this is the level that people have run pi to. And just if that makes it,
It's
it's
like,
mind-bogglingly large,
wow. Yeah.
and yet it doesn't resolve, it doesn't repeat, there's no
Well,
pattern.
and they've actually it was proven in the 19th century that you can't square the circle, that you can't solve pi.
Yeah.
It's impossible. But
But don't you
that
think?
doesn't stop people from trying, and
Yeah,
that's why
yeah,
the
yeah.
number, the a couple years ago is 50 trillion. Now it's 62.8 trillion.
Yeah,
In a
yeah,
few years,
yeah.
it'll be 100 trillion. Uh,
Yeah,
and why are people
yeah.
doing that? You know?
Because we think we can crack the code. But don't you think pi ultimately is like the absolute glitch in the matrix, because like you look at a circle, and in that very form is this incredible opening to infinity and eternity all in one, right there, like in your cup of tea,
Yeah, it
like
seems
it's
like
right there.
a simple question. Like I got a circle and its
Yeah.
diameter is one. What's the circumference? And
Yeah.
it's like it crashes the computer, you know?
Yeah.
It can't ever know that. And
68 or 62.8 trillion digits later, it's
yeah,
like, sorry, I can't help you.
but
So it
but
opens you.
we do have the ability to stop that stack overflow and just call it pi and get on with
Yeah,
our lives, you know?
yeah, yeah, yeah.
Yeah. So we do have that
But I
ability.
can't let it go like that. I can't just put it in a box and go, bye, see you later.
Yeah.
And now I'll get on with doing the dishes, because it opens something in my consciousness that makes me go, hang on a minute, like, what what exactly is going on there? Somebody, like, how can it never finish? How can it never complete? Why is there this gap, this opening that never ends?
Doesn't it
It's
feel like that is it's almost like peeling back the curtain on the illusion of reality, and you're like,
yeah,
I can see beyond it a little bit here through this idea of pi, and or through the idea of E, or through
yeah,
the fine structure constant. There's a lot of these ways in, or through what is light, what is a photon really, or
yeah.
what is gravity really. And the smartest physicists are like, well, at the end of the day, we don't know.
Yeah, exactly.
And you're like, what do you mean you don't know? Well, there's all this engineering that I went through, that I learned all this stuff, and you seem to know, but now you're
Yeah,
telling me in the inner sanctum that you don't know, really?
yeah,
And it's
yeah,
like,
yeah.
yeah, we don't. And
And
that's
do you know
what's so
what's lovely?
fascinating, is we don't have certainty. Life
Yeah,
doesn't have that certainty too.
yeah, yeah.
Yeah.
And do you know what I like about that, Scott? Like, here we have Mercury, right? He could have chose to transmit anything our way. You know what I mean? He could have just thrown out some random numbers that didn't mean anything, or it could have been like, different numbers. But the fact that pi, or at least even if it's just a projection of our consciousness onto Mercury, I don't think it is that, by the way, because it's too explicit in these two ways. And it opens you to this kind of like place where ultimately you have to surrender to not knowing. There's kind of a gentle humbleness that comes with it. It makes you humble. It kind of goes, wow, like pie, I'm never going to resolve that. Like, there's something I can't do. There's something like I'm not like I don't have the magic wand to go bang. Now, there we go, everybody. Geoff has solved pie. And there's a and then there's an opening to kind of a wonder. And I end up thinking about like how cool is that? Like, how cool is that all around us, not just in Mercury, but in the wheels of our car? There's this encoded message that like, lets you kind of drift off into infinity in
Yeah,
every single circle.
it's like it's a bit that living in that mystery and in that magical universe is there are invitations to that all around you, even in the wheel, the steering wheel of your car.
Yeah.
It's a shift of perspective, which is all that's needed to enter into these fascinating rabbit holes and opportunities for wonderment are there.
Yeah.
But usually we don't do that. We are just like more concerned with the practical, and fair enough. But when you have
Yeah.
the luxury of going into these things, you start to notice these doorways are actually all around you, in the
Yeah.
sunflower, the seeds of the sunflower, in the rainbow, in so many things in nature, you know.
And we
um
must do another video on Venus and talk all about phi in the sky there.
yeah.
I was thinking, I did a funny thing today. I had a look at the phrase pie in the sky. You know that phrase, pie in the sky? Ah, Geoff, you're always going on about mad stuff. It's a bit like pie in the sky. And then I now say to people, oh my God, like pie is in the sky because of Mercury. And everyone's like, oh, give us a break. And so I Googled, where does the phrase pie in the sky come from? And it was actually written in a song, I think like ages ago, like 1910 or something. And it was about like, I think it was about empty promises and false prophets or something. And it was like, when you die, you'll get pie in the sky. And it was kind of like a mockery that is like, that's an unrealistic nonsense. That was the tone of the song, right? And so we use pie in the sky as kind of to depreciate an idea or to bring somebody down to earth, if you like. But then I was kind of thinking with this whole Mercury trip, it's kind of like it puts that on its head, and it's like because they say cut out that nonsense and don't be talking about pie in the sky. But now this whole video is about, oh no, hello, hi, sorry. There is actually pie in the sky, and we can show you how in
Yeah.
two ways, you
Yeah.
know. And then what is pi? Well, pi is this thing that makes you go, I have no idea what's going on. I was just like, what is going? I mean, I can't follow that to 62.8 trillion digits. I'd be exhausted. And still I won't get anywhere further, than just being able to go, well, it's an endless mystery that goes to infinity, and I just have to leave it there. And in that act, there's two things happen. One is like I feel a bit humbled, and then I also feel like opened to something bigger than me. There's a sense of wonderment and awe in, wow, like it's just I just dig it. Like I just dig that Mercury is doing that thing in the sky. It's cool, you know.
Yeah, absolutely. And congratulations for finding pie in the sky for real, you know.
We'll have to, so maybe we can come up with a new song. Scott, are you up for that?
Yeah.
you know so look, maybe we leave this one here for now, but it was one I wanted to talk about for a while, and we'll be back soon. I hope you enjoyed that, and yeah,
Until
thank
next
you.
time.
Till next time.